You see it every day, right? That familiar, comforting presence in our sky? But what if I told you that friendly ball of light is actually a cosmic engine of almost unbelievable power and scale? Well, today, we're going to dive deep into the star we think we know.
Okay, let's just start with a number that's, well, it's kind of hard to even wrap your head around. If you took all the stuff in our solar system, I'm talking every single planet, every moon, every asteroid, and all the dust in between, and put it on a scale, 99.86% of that mass is the sun. It doesn't just sit at the center of our solar system. For all practical purposes, it is the solar system. And its size? Oh, it's just as wild. Get this, you could fit about 1.3 million planets, the size of Earth, inside of it. Go ahead, try to picture that. It's staggering, isn't it?
I mean, this incredible furnace totally dominates our sky and, makes all life on Earth possible. But what's actually going on inside that fiery ball? How does it even work? Where did it come from? And maybe more importantly, where's it all going? Let's find out.
So, first things first, let's get our bearings and talk about the basics. What is our star actually made of? And just how long has it been hanging around up there?
Believe it or not, the sun's recipe is ridiculously simple. It's almost entirely made of the two most basic elements in the entire universe, hydrogen and helium. Everything else, all the other elements, which astronomers just kind of lump together and call metals, that's just a tiny little 2%. The easiest way to think about it is this. Hydrogen is the fuel, and helium is basically the ash.
And it's been burning through that hydrogen fuel for a very, very long time, about 4.6 billion years to be precise. For a star of its type that puts it squarely in middle age, it's stable, it's predictable, it's about halfway through the main chapter of its incredible life.
All right, now for the really fun part. Let's imagine we could take this completely impossible voyage, plunging from the sun's hazy outer atmosphere right down into its very heart.
So here's our travel itinerary. We'll start in that wispy outer atmosphere, then dive through the bubbling, churning convective zone. After that, we'll have to push through the incredibly dense radiative zone until we finally reach our destination, the core.
But right away, just in the atmosphere, we hit a total head-scratcher. The sun's surface, the part we can see, is about 5,800 Kelvin. Hot, right? But its outer atmosphere, the corona, somehow blazes at over 1,000,000 Kelvin. How in the world does the air get so much hotter than the surface it's coming from? That is one of the biggest unsolved mysteries in solar physics today.
As we go deeper, we hit the radiative zone, and the plasma here is just unbelievably dense. To give you an idea of how dense, a single particle of light, a photon, born in the core, can take over 100,000 years just to fight its way out of this layer. It gets absorbed and shot out again over and over. And then, after that epic 170,000-year journey, it takes just 8 minutes to zip across space and reach us here on Earth. Wow.
And finally, we've arrived. The core. The temperature here just spikes to nearly 16 million Kelvin. The pressure is more than 250 billion times the pressure of Earth's atmosphere. We're in the very heart of the furnace.
And it's right here, in these absolutely extreme conditions, that the sun's engine just roars to life. Every single second, the core smashes together 600 billion kilograms of hydrogen. I mean, that's a number so big it's basically meaningless, but it's an unimaginable amount of mass being converted into pure energy every single second.
So, the process behind all this power? It's called nuclear fusion. The heat and pressure in the core are so intense that they're literally slamming hydrogen atoms together to create helium. In that little transformation, a tiny bit of mass gets lost. But thanks to Einstein's famous equation, E is equal to mc squared, that tiny bit of mass is converted into a colossal amount of energy. This is the reaction that has powered our entire solar system for billions of years.
So, now that we've taken a tour of the engine room, let's zoom all the way out and look at the entire life story of our star, from its birth to its inevitable death.
You can really think of the sun's life in 4 acts. It started out by forming from a giant collapsing cloud of gas and dust. Right now, it's in its long and stable adulthood, what we call the main sequence. But in about 5 billion years, when that hydrogen fuel in its core starts to run low, it's going to begin to swell up into a red giant. And its final act? It'll shed its outer layers and shrink down into a tiny, dense star called a white dwarf. And let me tell you, that transformation into a red giant will be nothing short of dramatic. The sun is going to swell to over 250 times its current size. It'll shine more than 1,000 times brighter than the star we see today. It's going to become a completely different kind of celestial object.
And that massive expansion, it's going to have devastating consequences for its closest neighbors. The surface of the sun will actually swell outwards, completely swallowing and vaporizing Mercury and Venus. And it might even expand far enough to engulf the Earth itself.
So after its spectacular and destructive red giant phase, the sun's going to take its final bow. It'll puff away its outer layers into space, creating this beautiful glowing shell of gas called a planetary nebula. And all that's going to be left at the center is the super-dense, Earth-sized core, a white dwarf. This little stellar ember won't produce any new energy. It'll just cool and fade over trillions of years.
So, from a simple cloud of hydrogen to a system-defining giant, and then finally to a fading stellar ember, the sun's journey is truly a story written on the grandest scale imaginable.
It's a pretty powerful reminder, isn't it? That even the things that seem the most permanent in our sky are all part of this vast cosmic cycle of birth, life, and death. Our star's story is still being written, and it really makes you wonder, what will ours be?